Hi folks, so this is differentiation by rule. So what differentiation is, so you'll have done differentiation by first principles before. So first principles, that's the f of x plus h minus f of x over h and the limit of x as x tends to h or h tends to 0 of all that. That's how you do it by first principles, but there's a shorter way, very shorter way, differentiation by rule. So this is how you differentiate quickly without having to do all of differentiation by first principles. But you could still be asked to do first principles in the exam. That's why you have to learn it as well. So what differentiation means anyway, it's the slope of the tangent, okay? So if you look at the graph here, I'll just talk a little bit about it first and then we'll get on to how you do it. So if you had a line like that, so or if we just had the line y equals x, for example, if that's the function, so f x is equal to x, so that's just y equals x, that's a very basic function, okay? So if you differentiate that function, if I differentiated this, all it'll give me is it'll give me the slope of the line. So it'll just give me the slope of that, because that line doesn't really have a tangent to it. It needs to be a curve to have a tangent. So if you differentiate a function like that, it just gives you the slope. So it's always slope anyway. But the majority of times you'll be differentiating things in maths will be when you've got some kind of a curve going on. So if we just had, say, that curve there, all right. What differentiating it is, so that curve, that'll be x squared, whatever. If I differentiate that, it'll give me the slope of the tangent, okay? But obviously you're going to have different tangents depending on where it is. So you could have a tangent there, you could have a tangent across there. Tangent is where it touches the curve once only. Or you could have a tangent, probably didn't draw that very well, you could have a tangent up there like that. Or you could have another tangent there. So if you differentiate a curve like that, it'll give you something with x in it, and depending then on where you want x to be, so if you want x to be at 2, for example, it'll actually give you the slope of it there. If you put in a minus 3 instead of x, then it'll give you the slope there, or wherever you put it in. But it's the slope of the tangent of the curve. That's what it always finds out. So you've any curve, if you want the slope of a tangent at any point on it, it'll find the slope of that. It doesn't find the equation of the tangent, it finds the slope of the tangent. So that's really what it's about. Now I've talked through that quickly. If you didn't understand really any of that, you can still get started. It's a fairly simple process to differentiate a function. I'm going to go through it here. So if you look at the rule, if y is equal to x to the power of n, so n x to the power of any number, then dy dx is equal to, so that's what this is then, that's when you differentiate, that's what it finds out. Dy dx is the same thing as slope of the tangent. It's just a notation for it. N times x to the power of n minus 1. So the power always drops down and you multiply by whatever the power is at the start. That's really all it is, and it's just a trick. So like if you don't understand what's in there, you don't really need to, it's simpler than it looks. So if I took y is equal to 4x cubed, okay, a nice simple example, all I'm going to do is I'm going to take the power, I'm going to multiply by what's in front of the x, so 3 times 4 gives me 12, and then I just drop down the power by 1 to a 2, because it was 3, so it just drops to a 2. So that would be if I differentiated that. Another example, so f of x is equal to 2x to the power of a high power, so 5. I'm just going to do 5 times 2, so I'll do the power times number in front, which is 10, and then just drop the power down by 1. That's all, okay? Yeah, so that would be, so f dash x and dy dx. So dy dx is the same thing as f dash x. It's just, you're asked for dy dx when they give it to you as y equals, but then if you're given f of x, like over here, they ask for f dash x, but them two things mean exactly the same thing. So if you're asked to find dy dx or you're asked to find f dash x, this is what you do. You just do this trick what I'm showing you. Right, if y is equal, just one more, 3, right, so 3x then, what would dy dx be then? Okay, so do the same thing as I've asked you. I'm going to do the power times the number in front, but here you don't see a power, but we know that it's a power of 1 if we don't see it. So I'm going to do 1 times 3, which is 3, and then I'm going to drop the power down by 1, so it's x to the power 0. So x to the power 0 is just 1, so the answer is 3. So that'll always happen when you have an x by itself. You're just going to be left with the constant in front. Last thing then, if you have a constant by itself, so if I had f of x is equal to 7, for example, or any just number by itself, so really that is x to the power of 0, isn't it? You could put an x to the power of 0 there if you want, because x to the power of 0 just means 1. So does the x on that doesn't have a power. 0 times 7 is 0, and then the x dropping down by 1 doesn't matter, because it'll be x to the power minus 1, but it's still times 0, so it'll just be 0. So if you have a constant by itself, it'll just be 0. You don't even have to go show that what I showed there, okay? So if I have f of x is equal to 17, I know f dash x is just 0. It's just gone, okay? So you don't have to worry if there's a constant. Right, let's have a look at this for example then. So f of x is equal to 6x cubed minus 3x squared plus 4x. So f dash x then, so they're asking us for f dash x here, but it could be dy dx. dy dx and f dash x are the same thing. But I'm just going to differentiate, so I'm going to take 3 times 6 and multiply them, so that's 18, and then I'm just dropping that power of 3 down to a 2. So x squared. I'm doing 2 times minus 3, which is minus 6, and x will drop down power, so it's just x to the power of 1, so just normal. And then that's an x to the power of 1 already, so 1 times 4 is 4. So that's my answer, and now it's asking us for f dash 2, so I'm just going to put a 2 in instead now and see what it is. So this is when the curve is at 2, then what's the slope of the tangent at 2, for example. So right, so put in a 2, so 18 times 2 squared minus 6 times 2 plus 4, and just use the calculator, and you should get 64 there. So that's the answer. So simple enough process. If you want to try one there now, so here, see the way they give you y and they're asking for dy dx, but we do exactly the same thing. So dy dx, if you want to stop the video and just try this, you'll have to change that 2 over x is the same thing as 2x to the power of minus 1. When you have an x on the bottom, you can put it up on top, but put a minus in front of the power. That's a rule, okay? So you'll have to change that to that. And over here, you should hopefully know x square root of x is the same thing as x to the power of a half. 4 over x squared, then I do the same thing I did in the first one. That's the same thing as 4x to the power of minus 2. So if you want to have a look at them and try them in video, and I'll go through the answers. Right, so first one, y is equal to 3x squared, and I'm going to change that, like I said, into 2x to the power of minus 1. Now I'm just going to do exactly like I did before, so dy dx is equal to 2 times 3 is 6, and then the power drops down to a 1, so it's 6x. Minus 1 times 2 will be minus 2. X, and then the power will drop down by 1. Now it's a minus 1 already, so if it drops down by 1, it drops down to minus 2, because minus 2 is 1 less than minus 1. So that's my answer then, and I could put it back, I could change it back so that I've got a positive x power in the second part there, so minus 2 over x squared. I could change it back to that if I want, but you don't need to. That there is fine for the answer if you're asked for that. Second one, so I'm changing it again into y equals x to the power of a half, and you'll get this now, because the other way, if you just had the ones I've shown you before, it's too easy. So they test you on knowing that square root is the same as that number to the power of a half. So minus 4 x to the power of minus 2. So dy dx is equal to, now a half times, and really there's a 1 in front there, it's just we don't see it, so a half times 1 is a half, and then drop down the power by 1. So what's 1 less than a half? So a half take away 1. You can do it on your calculator if you want, it's minus a half. Minus, and then, well, it won't be minus, it'll be minus 2 times minus 4, so that'll be plus 8. X to the power of, and then drop down the power by 1 is a minus 3. So let's tidy it up then. Equals a half, and I can put the x down below the line and change it to a positive, so that would be 1 over x to the power of a half is equal, plus 8 over x cubed. So I'm just simplifying it now. I have the work done, it's just to tidy it up a little bit. That will be the same thing as that on the bottom is x to the power of a half is the same thing as root, so, and times the two of them, so 1 over 2 root x plus 8 over x cubed. So that's dy dx, so a little bit harder for that one, and that's it.